In this video, I'm going to be going over how to make a electromagnet, just like this one. Sorry, not electromagnet, electric motor, and how it works. So first, you can see you can build one using some very simple materials. Now let's get into how it works. So, see a bunch of drawings here. They'll all be explained in a minute. You can see in this one, there is that's hot. It's a central coil, and it's connected to a battery. And it is within the coil is within a magnetic field. If you look over here, we have a coil within a magnetic field. And that coil has current flowing through it. See here, here's a side profile view. So, if you were to take a look at this coil right here, see there's current flowing through this way and it's flowing through the coil clockwise. Now, when the current is flowing clockwise and the magnetic field is going up, you can use the right-hand rule that we've talked about here to see that with the current going right, for the top of the coil, the current going right, the field going up, magnetic field going up, you're going to get a force pushing that way, right? So that is a force on the top of the coil here. That is a force pushing towards you. Now, on the bottom of the field, the current's going the other way, right? So we have the current going that way, the field going that way, and then, now our middle finger is going down into the page. So that's going to create a torque. Now, a side profile of that, because it's kind of hard to draw forces in and out of paper, side profile of that. So here you have the top, you have the current flowing into the paper, or out of the paper. You have current flowing out of the paper. You then have a magnetic field going up still, which means force is going to go that way. Bottom, whoop, it's spinning the other way around. And the field's still going up. So the force is going the other way. That's going to create a torque. You can see here, there's the coil, much fancier drawing, but this gets the point across quite well. Magnetic field's still going up. So, but you might say, what happens when it spins around? Won't it just, like, lock up? Well, you have to make sure that when you build it, you have to have the field turn off, because when it flips to that, I knocked my thing over. And it stayed spinning when I put it back up. See, that's just how good it is. Now, you might say, what happens when the current switches the other way, or when it's gone upside down and the current's now flowing the other direction? Well, that's not good. Because then, there's my fingers. Because then the motor stops, right? It'll just end up locking itself parallel with the magnet. It would end up locking itself like that, right? Instead of spinning like that. So, what you have to do, again, this when you build it, what you have to do is make sure that the motor is off when the coil is facing the other direction. So when the current in the coil is flowing this way, right, when the current in the coil is flowing like that, it has to be off. Now you can do that either with you can do that with enameled wire, because you need to build it. So, I think we've gone over enough how it works. You can see with the right-hand rule, you learn that with the current flowing different directions at the top, at the bottom, all within a constant magnetic field, you're going to create a torque. And then, when the coil is facing the other way, once it's rotated 90 degrees, my motor stops spinning. You've got to keep spinning, motor. There we go. Now, when the coil is facing the other way, you have to make sure it's off. Otherwise, it's just gonna lock itself parallel. Right? It's going to create a torque. It's going to rotate around the center of mass. Or in this case, the one we're building, it's going to rotate around its pivot points. So now, how do you build one of these? The first thing you're going to need is some enameled copper wire and something to coil it around, like a chapstick. Anything really works. You could use a pencil. Probably going to be easier to find some pencil. The next thing you're going to need is a magnet. Neodymium magnets are the strongest for their size that you can really buy. I would recommend a neodymium magnet. Not that expensive either. If you just want to use magnets you can find around the house, you can find some ceramic magnets. Let me grab one from here. Still very strong. Let's hope I don't break these magnets by bringing them too close to each other. Find a ceramic magnet, still quite strong. Not quite as strong as this. These magnets, despite being very different sizes, you can also see here very different thicknesses, right? It'll be easier to base your motor on. This one are probably about the same strength. This one might be a little bit stronger. So now that you have that, you need a battery like this to build this style, right? It doesn't have to be this big, but it needs to be like the AA, AAA, or D shape, the cylindrical shape with anode and cathode on either end. Then paper clips. Shape them like this. I don't really know how to describe doing it. You kind of just pull one end around the other way. So you pull the end to be from down here, and when you pull it up, you pull it right, you make this nice little loop in the middle. Now you also got to make sure your paper clips are not coated in anything. Come on, magnet. Kind of hard doing this with one hand. Oh, now it's just stuck to that. I'm gonna leave it on there. So you need to make sure it has that little loop there. Tape it on. Do it with E-tape. Be smart. Don't be like me. Use electrical tape. I have a little ball of it right there. But just use electrical tape. Be smart. Okay. Anyway, so with your enameled wire coil that you've made, preferably with 15 to 20 coils, 10 will probably work, but 15 to 20 is what I've found. It keeps it light enough, but also it has enough coils to spin well, because if you remember here, if you remember back to your Physics 12 class, more coils, stronger. Yes. So now, once you have made these, made sure they're level when you put it down, right? Make sure the holes here are the same height. And you put the magnet on the top. Doing this with one hand is harder than I thought it would be. Put it so it lines up, just like this. Now you're gonna put your coil on, you'll be like, why is it not working? Nothing's happening. Matt lied to me. I didn't, I just haven't told you everything. You're gonna need to take some sandpaper. And you're gonna wanna, on one end, remember which end, shave it down all the way on all sides from where the coil starts to the very end, right? So do it on one end and leave the end unbent, just perfectly straight. Then on the other side, remember we talked about how current needs to be flowing in only one direction? Take that same sandpaper and sandpaper one side. Only one, right? Sandpaper down just the top or just the bottom, or I guess it'll be the top when you're sandpapering it, but just pick one and put a bend in it so you know which one it is. Doesn't really matter, but just so that way you don't go, oh, there's not enough connectivity. I need to sandpaper it some more, and then you end up sandpapering all the enamel off on the other side, right? So have your half enameled side, so that way when it's like this, current will flow because it'll connect from the bottom because gravity's obviously pulling it down. So it'll connect from the bottom, current will flow nicely, and then it'll flip over, and suddenly no current's flowing. It'll flip over again. Oh, current's flowing, it's gonna wanna spin, and it's gonna spin, and then no current's flowing. But then because you made it heavy enough with enough coils, it's gonna carry its momentum over. Oh, there's a big force pushing it. And then it's gonna carry over. Big force pushing it, and it's gonna spin. And it should, if you did it all right, should hopefully, come on, spin like this. Also, that bend serves a second purpose. It keeps it in. And there you go. That is how you make an electromagnetic motor. DC. This is not an AC motor. If you're trying to build an AC motor, you have bigger problems.